Hopefully that mic's all right. Let me know. I'm a loud talker, so you could probably hear it without me, to be honest. Hi, it's lovely to be here with you all. Thank you for coming to this session today and staying, because I know it's getting late in the day. People are getting tired. I'm glad there's popcorn. I'm slightly jealous. I might have to grab some afterwards. So my name is Grace Jansen. I'm a developer advocate at IBM based in the UK, if you couldn't tell from the accent. So please don't try and speak German to me. I've learned zero German. I know a tiny bit of French, but English is A-OK. So yeah, I mostly work on sort of advocating for Java technologies, whether it's presenting like today or writing blogs or tutorials or demo applications, mostly in the Java space. But originally, my background is a biologist, because the two go really well hand in hand. My knowledge of fish has come in really handy as a software developer. So what I try and do during talks like this is bring in biology to try and simplify and come up with analogies to kind of what can often be very complex and convoluted software architecture principles or software engineering principles. So today, I'm hopefully going to do a bit of that with some cloud-native observability. And we're going to take a look at how we can become a cloud-native doctor by using sort of metrics and specifically tracing to help diagnose our cloud-native applications. So there's obviously an obvious connection. Can you all tell already? So medicine and software engineering, how do the two fit together? What can we learn as software engineers or architects from the field of medicine? When it comes to medicine, doctors spend years studying and training to be able to accurately diagnose ailments, illnesses, and potentially terminal conditions. It takes them a very long time to understand what is a very complicated machine. The human body is a complicated machine at the end of the day. So being able to understand from essentially what is often biometrics, what's going on within that body is a very complicated topic. But doctors and physicians can use a wide range of different biometrics to try and find out what's actually going on underneath the covers. Things like, it might be physical symptoms, so is the person looking well? It might be things like written notes, it might be actual machines plugged in, so heart monitors, monitoring things like blood levels, taking samples and analyzing those. So there's a lot of different types of metrics that doctors take a look at. And we do similar stuff in software. We're diagnosing with metrics just like doctors do. So although we might not be looking at a person's health, we're looking at an application's health. We might be looking at, okay, what are the API requests being made to it? How's the memory consumption doing in my cloud-native infrastructure? How's the network traffic doing? Is there any errors coming through? What are the logs looking like? So there's lots of different metrics that we collect. You might already be doing a lot of this already yourselves to be able to diagnose our software applications. But what we're missing is the next step, and that's the difference when it comes to medicine between diagnosing an adult and diagnosing a baby. And there's a few speakers around here with kids today, so it's been quite a fun analogy to be able to mention to them. When you bring a child in, if any of you are parents, bringing in a baby or a toddler into the doctor, if you weren't there, there would be no one to give the all-important context that is needed to actually, effectively diagnose someone correctly. Because the same physical symptoms and the same physical metrics might lead to two completely diagnoses with different context. For example, if I've got a headache, well, if I fell over and bumped my head, it's probably just because I bumped my head. But if I've got a headache and there was no context, someone might say, oh, well, it could be a multitude of things. You might have a brain tumor. We're going to the extremes here, but you might have a brain tumor. Maybe it's a migraine, or maybe you're dehydrated. There's lots of different things that potential symptom could be, but being able to add in that context of, have I had an accident? Have I started a new hobby? Have I had a change in my diet? There's lots of different elements in that context that can help doctors to diagnose. And I think that's what we often miss when it comes to cloud-native observability and cloud-native applications, is that all-important context. We're looking at a bunch of numbers, but where they fit in our application and what's caused them is really the important added step that I think we need to take. So we're going to take a look at how can we become cloud-native doctors by following this kind of practice in medicine of adding in that context. And to do this, we're going to take a look at adding in observability and specifically distributed tracing. Why is distributed tracing important? We're going to go on to that in just a minute. So when it comes to implementing observability, it's actually fairly simple when you think about it conceptually. There are essentially 3 steps to take. The first step is to instrument our applications. If we're not allowing or enabling our applications to actually send out or collect metrics, or whether it be metrics, traces, or logs, or anything else, there's really no point to the other 2 steps because there's no data in the first place. So this is a critical step here, really. So instrumentation of our apps is that first step. Second step is once we've actually collected that data, whether it be from our system or from our application, is we need to then send that data to a separate external system to be able to store and analyze it. You might already be using tools for this, like, for example, Jaeger, Zipkin, Hotel Collector, whatever it might be. These are useful tools to be using to then sort of take the emphasis away from having to do this locally in your own application and separating out that concern and being able to send it somewhere else for storage. So you're not having local data storage in your application if that were to go down or you needed to spin up a new instance, for example. The third step is, okay, now that we've stored it somewhere else, we've analyzed it, it's all well and good storing and analyzing that data, but as humans, if we can't interpret that data and understand it, then there's not much we've really gained from that data to be able to actually, put in place, say if there's a failure, to be able to fix that failure, or to be able to improve our application performance. So visualizations and insights, that third step, is a really important step for us to be able to actually understand, okay, what's happening with my application and why is that happening and how do I fix that? And again, you might be using existing techniques or tools like Prometheus, Grafana, Kibana, for example, all tools that you can use to be able to provide those visualizations and dashboards. In this session today, you'll be pleased to know we're not doing all 3 because you'd be here all day. That would be a whole workshop. We're just doing that first step. So we're just taking a look at how do we effectively instrument our applications, specifically Java applications in this case. Is anyone not a Java developer here? No? I mean, a couple of people? Okay, there are some other, like, the open source technologies I'm going to talk about, there are other languages you can use them with, but I'm specifically focusing on Java, and given most of the room is Java developers, hopefully that's helpful. So yeah, today we're going to be looking at instrumentation. So in order to instrument our application, we're going to look at 3 key pillars. These are the foundational pillars of observability in our application. That's not to say these are the be-all and end-all. This is not an end-to-end list of everything you should be collecting in your application. There are other things that can be added to give additional information and metrics on top to add to that observability insight that you're looking at. But these are the 3 core pillars that are included in most open source specifications and methodologies when it comes to observability. So the one we're going to be taking a look at today is Open Telemetry, and Open Telemetry enables all 3 of these pillars. Actually, the Open Telemetry community is starting to expand and take a look at other types of data that you could collect as well. So as well as logs, metrics, and distributed traces, there's also things like profiling data, for example, end-user monitoring, so seeing how someone actually interacts with your specific system, for example, being able to understand where our code spends most of its time, what's taking up that resource. So these additional pieces of data can really help to add additional just insight, really, into what's going on. But just now, just to keep things simple, we're just going to focus on those core 3. But I just wanted to give you an idea that it's not an end, this isn't everything. There are other things to consider as well. So the first of those pillars is logs. I'm not going to spend too much time on logs because I'm assuming most of us use logs, probably on a day-to-day basis. But just to sort of put it in there as this is a key pillar, being able to capture events or time-stamped messages that happen at a particular point in our application can be especially useful if there's a particular error that we're trying to catch or a failure that's occurred. But logs are fairly simple, really useful in development, but they don't give us the entire picture because they are at a time-stamped point in our application. And that's where adding metrics can really help. Because what metrics allow us to do is have data that's a lot more malleable to statistical transformations. So being able to understand not just what's happening at my application at one specific time point, but being able to understand what's happening to my app over a period of time. So being able to understand trends, is my memory usage increasing or decreasing? How's my CPU usage? Being able to analyze these over a period of time really allows us to gain understanding sort of at a wider level and understand how our application, sort of the norm of our application, and whether it's differing from that and we need to do something about it. However, the biggest drawback with application logs and metrics is that they're system scoped. So it's really hard to be able to understand anything else other than what's actually happening within that system. So this is where, logs, without fancy joins, a single line doesn't really give us much information about what's happened to a request as it goes through multiple different microservices often in what is a distributed cloud-native application. So what we need is to be able to add that all-important context, which we can do with the third pillar, distributed tracing. We can go beyond that system scoped. So I call it distributed traces because most of the time this is, I'm applying this to cloud-native distributed applications, but often people just refer to it as tracing, depending on how you want to refer to it. So distributed tracing is the one that many people don't already have in their applications. And this is the ability to be able to record a path by request. So it's basically what happens to a single request as it gets transferred between multiple microservices end to end. So how does it go from the start when a user requests it, or say another microservice requests it, all the way through to the end? What microservices are involved? What happens? Understanding all of that is what allows us to be able to provide that additional context. So it's a monitoring technique that really links the operations and requests occurring together in a distributed environment. So it is a really important third pillar that adds on top that additional information on top of logs and metrics. Now, there are some key concepts to be able to understand before I dive into a demo of tracing, and they include 3 key words. The first of those is a trace. So I just want to make sure everyone's on the same page with this in case people haven't come across this before. So a trace, as the name kind of suggests, is just a representative of requests, and it normally consists of multiple spans. So I've got a diagram here. You can see the trace is represented by that orange line at the bottom, and you can see it's consisting of multiple spans, which are those pink or purple, however it appears, pink boxes belonging to sort of each microservice there. So what is a span? A span is all about sort of being representative of a single operation in a request. It normally contains basic information like name, timestamped information, might have some log messages in there, and some metadata to really give us some information about what's occurring during that particular transaction. So it's by combining multiple of these spans that we can then get our final trace to understand what's going on. And there's the final thing, which is context. So this is really where we start to get into that sort of analogy back to medicine, where we're understanding where it fits into the bigger picture. So context is an immutable object that is normally contained within that span data, and it helps us to identify the unique request that it's a part of. Normally, the trace context is typically composed of 2 different things. You've got the trace ID and you've got the parent ID, represented in my diagram here. So the trace ID is the unique identifier that's generated at the very root of the span, so right at the very beginning here. And it's what allows us to be able to understand that each of these spans is part of the same trace. So the trace ID stays the same throughout that trace for each span involved. The parent ID, on the other hand, changes, because the parent ID is what allows us to be able to order the spans in order as they went through that trace. So the parent ID is the span ID of the parent that spawned that current operation. So that was a lot of words. So hopefully the diagram makes it easier. But essentially, as you can see here, the parent ID for that first bit of information, that first context, is the same as the span ID on the browser application. So ABC123. The following piece of information, you can see that parent ID changes, but the trace ID stays the same. So the parent ID becomes DEF456, which is the same as the span ID of its parent that created that operation. So what that allows us, that combination of those 2 pieces of information, they allow us to be able to understand, right, all of these spans are all part of the same trace. And actually, if I was to go through and look at them randomly, I'd be able to understand that actually this operation was created by this microservice, and this operation was created by this microservice. And that allows us to be able to backtrace, to be able to more accurately pinpoint where a potential failure or bottleneck may have occurred within that trace. So allowing us to really accurately work out, where did something go wrong? Why did it go wrong? What happened before it? What happened after it? And what can I do about it? So it's that really important information that we tend to lack when just looking at logs and metrics. So that's tracing, that's observability, that's how we enable it. Easy peasy, right? So that's kind of the theory. And theory is one thing, but how do we practically apply this and enable it in our own Java applications? And that's where open source technologies and tools like, for example, Open Telemetry come in. So, in the past, it's not as if we didn't have a way to be able to do all of this, but generally, applications were instrumented, and that instrumentation would vary because each back-end system normally required very specific code within your application to actually connect with it. There was no standard, there was no sort of ubiquitous way to be able to enable observability in your application and be able to effectively and easily change that back-end. And that's where Open Telemetry really came in, to be able to provide that single standard. So it's there as a sort of high-quality, ubiquitous, and portable telemetry to enable effective observability. Originally, it was created from 2 other open source projects. So you may have come across things like Open Census or Open Tracing before. Open Tracing provided a vendor-neutral API for sending telemetry data over to observability backends. But the difficulty with Open Tracing was that it relied on developers to implement their own libraries to be able to meet this specification. Then you had Open Census. So Open Census provided a set of language-specific libraries that developers could use to instrument their code and then send it to any of the supported backends. But the difficulty with Open Census and Open Tracing is that there still wasn't one standard. That's 2 projects. That means 2 standards. That means there is no single standard. So they kind of realized this, and of course, each of them had their individual drawbacks. So they decided to take the best bits of each project, combine them together, and actually truly make one standard, which is now Open Telemetry. The nice thing about Open Telemetry is that it is a growing project. It's actually the fastest growing CNCF project aside from Kubernetes. So it's got a lot of backing, a lot of community sort of backing, and people contributing to it already. The one thing I would say is that Open Telemetry is fantastic, but a lot of people look at Open Telemetry and think, great, that's my solution, that's all I need. The thing to note here is Open Telemetry does not, I repeat, it does not give you a full observability end-to-end solution. Open Telemetry allows you to be able to achieve that first step of those 3 steps we went through, that instrumentation. What it does not do is enable you to, collect and analyze and visualize that data. So what you need to do is utilize Open Telemetry with other tools like Prometheus, Grafana, Kibana, whatever it might be, to be able to actually achieve that end-to-end observability. So that's just one thing to note, is it won't give you that full package. It is designed to be used with other tools, like those visualization tools. So yeah, this is basically to sort of meet those problems that we were looking at earlier, where trying to come up with a way of standardizing it and sort of making it easy to use. So the way that it works, this is kind of the architecture that you might see in a typical application making use of it. So we've got microservices, however many we might have for our application code. We've also got some shared infrastructure that we're using down here, and we're actually collecting information, data from both to be able to send to our central collector and then send to any particular backend we might want to, depending on what we're using to visualize and collect and store. You might notice the word OTLP on this diagram. We're in tech, we love acronyms. When I joined, it was like Latin, like every Scrum. I was like every other word I didn't understand. So I try and make sure that I explain acronyms as much as possible in my sessions. If I don't, raise your hand and I'll get onto it. But OTLP is short for the Open Telemetry Protocol. So this specification describes the encoding, the transport, and the delivery mechanism for that telemetry data between those different sources, intermediate nodes like collectors, and the telemetry backends. So it's the way in which we can standardize being able to send over and how we sort of encode and deliver that telemetry data. That collector in the middle there is essentially a vendor-agnostic implementation on how we can receive, process, and export telemetry data. Normally, it's a single binary that tends to be deployed as an agent or a gateway. Looking more into the collector, so the Open Telemetry collector is one collector you can use. That offers a vendor-agnostic implementation for that receiving, processing, and exporting of telemetry data. What it means is it really allows you to be able to remove the need to run, operate, and maintain multiple different agents and collectors. So you can just have it all in that one central collector. And it improves things like scalability. It supports open source observability data formats like Jaeger or Prometheus or FluentBit, and sends it to one or more open source or commercial backends, depending on what you're using. You might be wondering, why would I use a collector when I could just send straight from the source to my backend? And that's a totally valid question. What we'd say is that if you're just getting started with Open Telemetry, if you've got a really small demo application and it's not really going into production, you're just using it to try stuff out, absolutely, send away. Go straight from your source to the backend, no problem. However, if you have sort of a production system that you're wanting to use this in or a bigger application, in general, we would recommend using a collector in there and not just sending it straight from the source to the backend. And that's because it allows your service to offload data quickly. It also allows the collector to really take responsibility and care of handling additional things like retries, for example, encryption if you need it, batching, or even things like sensitive data filtering. So it takes the responsibility and the onus off your application to do that, and means you can give that responsibility to the collector, and it helps to standardize everything in your application as well. So it's a valid question. You might not need to use it if you have a small application or you're just starting out, but we would recommend to use it if you're going into production. Okay, so that's Open Telemetry. But remember, Open Telemetry is a specification, so you're going to need an implementation of it if you're going to use it in your applications. And MicroProfile Telemetry is sort of the newest one in Java that really allows you to be able to make use of it in a Java application. So has anyone come across MicroProfile before? Couple of hands? Cool, but other people know. Okay, for those people, bear with me. I'm going to do a super quick intro, and then we'll dive into telemetry. So for those of you who don't know about MicroProfile, MicroProfile is an open source specification that's really been designed and developed by the community. There's a whole bunch of different vendors and individuals who are contributing to this, and tons of different implementations that make use of it as well. So what it gives you is it's really designed to take enterprise Java, Java EE or Jakarta EE, and build upon it with additional APIs and capabilities that are designed for microservices and for cloud-native applications. So it started with just a few APIs. There was about 4 or 5, and it's sort of continued and expanded since then. We're now on to MicroProfile 7, and I'll speak more on that in a couple of minutes. But really what you get with it is sort of the core different features here at the bottom. Some of those are shared with Jakarta EE. If you've not come across Jakarta EE, it's really an open source of Java EE. So some of those are shared, but then you get additional APIs like Open Telemetry, which we'll go into, but other things like Open Tracing, being able to check on the health of your application, metrics, which we will go on to because that has recently changed, and things like GraphQL, reactive if you want to do reactive, JWT if you want security. So there's loads of different capabilities from MicroProfile that you can make use of, and it's all open source. The nice thing about this is that because you're using an open source shared standard, a specification, if you want to port your application between different implementations, it means minimal code changes. So there's lots of different implementations for MicroProfile. You can see the ones that I work on are OpenLiberty, Webs for Liberty, but there's lots of different ones like Quarkus and Wildfly and Pyara, JBoss, loads of different ones in there that implement MicroProfile. So it really is a shared community and enables a lot more flexibility and portability for your application. So MicroProfile Telemetry was first introduced in MicroProfile 6, and this implemented the Open Telemetry specification. So it allowed you to be able to make use of that in your own Java application, and sort of to be able to enable it. If you're already using things like Jakarta REST for web services and CDI from MicroProfile, these are 2 other APIs, then it enabled you to be able to automatically enlist in distributed tracing, which was pretty cool without any code changes. I'll show that in my demo in a minute. But there has been some recent changes. So MicroProfile 7 literally came out on August 22nd, and at the moment it's only available in the Open Liberty beta, so it is pretty new, and it's quite exciting. There's been some significant changes that have occurred, so for those who do know MicroProfile, hopefully this is some new information for you. What's occurred is we've now got Telemetry 2.0, and Metrics, which was in the standard stack, has now moved over and is a standalone project aimed to be deprecated. The reason for that is that although metrics are really important, we haven't gotten rid of metrics. We've just replaced it with a different kind of metrics. So originally, before Open Telemetry existed, MicroProfile metrics was created to fill that gap. Now that Open Telemetry has grown to be such a big community and such a standard, it was decided by the MicroProfile community that it made sense to get rid of the MicroProfile metrics and to adopt the Open Telemetry metrics. So now in Telemetry 2.0, you can also, as well as doing tracing, which was enabled in the first MicroProfile metrics, MicroProfile telemetry, in Telemetry 2.0 you can also do tracing, metrics, and logs through Open Telemetry specification. So it's trying to merge all of that telemetry data together under one API to make it a lot easier to use. But that's the new stuff that's arrived in MicroProfile 7. And as I say, it enables you to be able to have a set of APIs designed for the creation and management of telemetry data, including traces, metrics, and logs. And if anyone is a MicroProfile fan and wants to hear more about that, there's a presentation that I linked to here. You can go and check out why they made those changes with the issues in that open source community. But given most of you are new to MicroProfile, we're just going to dive into telemetry data. So the way that you can use MicroProfile telemetry is there are 3 different instrumentation options. The first option, automatic. So automatic instrumentation requires no code changes to your application if you're already making use of Jakarta RESTful Web Services and MicroProfile REST Client. So these are 2 APIs from the Jakarta E and MicroProfile community, and it means that if you're already making use of them, which if you're already using MicroProfile and Jakarta E, you probably are, it means you can just automatically enlist in distributed tracing automatically. The second option is manual instrumentation. So that uses annotations, which is a really common, most of the MicroProfile APIs use annotations. So in this case, we're using annotations like with span or inject tracer, inject span, to be able to manually add in and have more control over the tracing that happens within our application. The third instrumentation is agent. So that's making use of Open Telemetry's Java instrumentation project to be able to gather that telemetry data, again, without any code modification. So 3 different ways that we can do it in our Java application. I think I'll have time for 2 in the demo today. But the nice thing is you can do this demo yourself. It's a lab that you can go through in your own time. And it doesn't require any local prerequisites. So if you have a restricted machine, no problem. You just need a browser if you do want to have a go yourself. So how does MicroProfile telemetry work? This is sort of an architectural diagram just to showcase sort of, we're taking in requests into our application. In the application I'm going to show in my demo, it's super simple to try and make it easy to understand. There's just 2 microservices running on Open Liberty. Actually, that's a good question. I haven't introduced Open Liberty much. Has anyone come across Open Liberty? Yeah, that's the same hand from MicroProfile. Yep, got a couple of hands. Okay. So Open Liberty, I would normally be wearing an Open Liberty t-shirt, but I thought I'd adopt the Basil 1 today. Be with the team. But Open Telemetry is an open source application cloud native runtime. Has anyone come across WebSphere? There's a few more hands, unsurprisingly. So we had WebSphere. WebSphere is, to put it politely, a bit clunky, a bit hard to use, a bit big, a bit annoying for cloud native deployments. I'm getting some nods. Yeah. So we kind of realized that, and we were like, do you know what? We need to start again. We need to make something that enables the same characteristics and features and great functionality that's in WebSphere, but make it much easier to use and much more sort of in line with cloud native requirements for cloud native applications. So we kind of started again and made a new project called Liberty. And then in 2017, we open sourced that to create Open Liberty. So it's still got the same sort of great functionality that WebSphere offered, but it's lightweight and much easier to use and designed for the cloud. So I'm going to demo that in my application today. But essentially what we're going to do is we're going to utilize Open Telemetry protocol. We're going to be using Jaeger in this case, and we're going to be collecting spans and traces from our application. I'm going to take a normal application that's not using traces and add in traces with 2 of those instrumentation options I showed earlier. So as I said, demo time. So this is Open Liberty. If you want to find out more about it, we have a website, openliberty.io, and on there you'll find a lot of our guides. I'm going to go through one of the guides today, and these guides allow you to be able to very quickly get up to speed with open source specifications and APIs. So if you're interested in any of the MicroProfile APIs I talked about but haven't covered in this session, we have a guide for all of them. They're all open source. You can check them out on GitHub if you want to do it locally, or you can use our cloud native environment, which we're super proud of. So like, hopefully you guys go and try it for yourself, give us some feedback. This allows you, as I said, it means you don't need any prerequisites locally on your own machine. You can do it all within a browser. It's like a Thea-based IDE. So you get your IDE, your terminal, and your instructions all in the same browser tab. So it makes it quite easy to be able to go through it. So we're going to be using that today. So I'm going to try, and hopefully it's remembered me. Cool. Are we still running? Yes, we are. Perfect. Okay. So in the interest of time, to make sure I could go through at least 2 instrumentations, I have already gone through some of the steps in this guide. Now, the way I got there was just I went to the Open Liberty website. So this is the Open Liberty website. We've got lots of things like documentation. We've got a blog. I run the blog. So if you have an idea for a blog, let me know. I'm always interested. But we've also got all these guides. As I said, we literally have, I think there's over 60 guides now on loads of different topics. So please do go check it out if you're interested in any cloud native tutorials, because we've probably got one on there that you might be interested in. So to get to the observability one, I just went to the observability section, and you can see it's got this running cloud button. Now, if it doesn't have a running cloud button, that does mean that you'll need to do it locally. There's only a couple of our guides that have that, and that's because of the way in which we've set up the cloud native environment. Sometimes it can be challenging to run a cloud within a cloud within a cloud, and it gets a bit complicated with things like access management. So some of them you have to run locally, but most of them have this running cloud button, as you can see on the screen here. So yeah, you can have a go with them that way. So this will take you through to this page. So we're doing the Open Telemetry with Jaeger lab today. If you don't want to run it in the cloud native environment, or if you're doing one of the labs that doesn't run in that environment, then just make sure to look at the prerequisites that appear in the top right-hand corner, because those are the ones you are going to need locally if you do run this locally. So when we click on the running cloud option, it will open a page like this, and it will ask you to log in. There are lots of different login options. We didn't have a login to start with, and then Bitcoin miners found us. So we very quickly had to add a login, because that kind of crashed the system. So we do require you to log in, but you can log in with things like social logins or GitHub. And given many of us are developers, hopefully you have a GitHub account that you don't mind using. So in this case, I'm logged in with GitHub. And when you click on Access Cloud Hosted Guide, it will take you to a page like this. So this is our cloud native environment. How is the font? Big enough for everyone? Yeah? Perfect. Great. So in here, we have the instructions on the left, we've got the Thea IDE in the right here, and we've got the terminal at the bottom. So in this case, as I said, I've already gone through and done some of the instructions myself. What you'll get with most of the guides is a basic intro section, which will tell you about what we're going to be doing in this guide, what's the point of it, what are we learning, and then it will tell you about sort of the basic technologies that are involved. So in this case, Open Telemetry. As I've already gone through that in the lab, in the presentation, I'm not going to go through all that again, so we're just going to skip that part. But essentially, as I mentioned, we've got 2 different microservices in this application. This diagram gives you an idea of them. We've got the inventory and the system microservice. Very, very, very simple. We keep most of them, in most of the guides, it is the same application. So you'll see the same microservices again and again. So you can just focus on learning the new technologies rather than trying to understand a brand new app. So the inventory microservice essentially scrapes inventory, the sort of system data every 15 seconds. And then it is able to, the system microservice is essentially just a store of that information from the inventory microservice. So it's not a particularly sophisticated app, just nice and simple. So what I've done is I've cloned the GitHub repository. As I said, all of this is open source. If you want to go and check it out, you can do. And I've run this Docker command to be able to start up my Jaeger UI so that we can actually see what's going on. As I said, we're connecting that Open Telemetry to Jaeger in this case. As well as that, I've also started my 2 microservices. So in all of our guides, the way that we lay it out is we have a start directory, as you can see here, and a finish directory. The start directory is where you're going to start at the very beginning of all these instructions, and it is a half-baked application because it's waiting for you to complete the rest of the steps. If you want to cheat and skip to the end, you can do if you want. You can just head straight to the finish directory, and the finish directory will give you all of the finished code that you will come to at the end of all the instructions. It's a nice way of comparing. If you go through the instructions and you make a mistake, for example, you can go and compare to the finish directory. But we're going to skip that. We're not going to go to the finish directory today. We're going to start from the beginning with start. So what I've done is I've run some of these commands already. So let me get rid of this. So I already have 2 terminals open here and here. And what I've done is I've taken the 2 microservices, so the inventory and the system microservices. I'm running them with Maven in this case. We run all of our guides with Maven just to keep consistency. If you want to use Gradle, you can use Gradle. If you want to use Ant, I'm not going to judge, but that's your choice. So with Maven, in this case, we're using a Maven command, which is liberty dev. You could run liberty run. That will run your application as normal. It will just run the application, run the microservice, and you'll need to tear it down if you want to make any changes. The difference with liberty dev mode is that it automatically picks up any changes that happen in your code or configuration classes. So it means instead of having to run your microservice and then tear it down and restart it whenever you want to see a change, it automatically picks those up without you needing to do that. And it just recompiles the classes that have changed. So it means that in our labs, for example, we can be really dynamic and change lots of things all at once and not have to tear it all down and start it up again. So I've launched both of these in liberty dev mode so that we can do that. So if I scroll down on this one, for example, what you'll see, you'll know it's ready to run if you use liberty dev mode when you see this really helpful message of loads of stars and Liberty is running in dev mode. So I've got the system service in that terminal. I've got the inventory service in this terminal. The one thing to note is those terminals are now used up. So I can't use those terminals for anything else because they are running in dev mode. They're constantly listening for those changes in that code and configuration. So I'll need to open a new terminal to be able to do any curl commands or anything else I need to do as a command for this lab. So I've got that 3rd terminal open for that. I've already done these curl commands just to sort of hit the endpoints and make sure that my system and inventory microservices are up and running. So I can just go to the next slide, which is all what we're here for, which is enabling telemetry. So I've tried to make this as quick as possible so that we can get to the nitty-gritty fun stuff. So, enabling telemetry. So as I said, MicroProfile telemetry is what we're using here. And to be able to use that, we need to make sure that we have it listed in our server.xml file so that we actually have it available. So the first thing I'm going to do is edit that file. So if I make this a bit smaller. In our labs, what we do is we provide all of the code that you'll need for that particular class or file. So you can just copy and paste over the whole thing. So I can select all of that, delete, paste, and remember to save. This environment does not auto-save, so do remember to save. Or, if you really want, you can go through all of this code, find the differences, and add them in yourself. It's really your choice. But in this case, all we've done is we're just adding in this feature to enable MicroProfile telemetry in our applications. So we've just done that for the system microservice, and now we need to do the same thing for the inventory microservice. So if I open up my server.xml for that microservice, select everything, delete, paste, and save, you can see that I've, again, added in this MicroProfile telemetry feature. Weirdly, and I do think this is really weird, the default for MicroProfile telemetry is that it's off. I don't know why. So you have to go and make sure it's turned on. So to do that, we're going to be adding in a MicroProfile config properties file. MicroProfile config is another API that you can use to enable externalized configuration. So you can separate out the configuration from your code, enabling much easier for you to be able to deploy to different environments with different configuration. So in this case, I'm going to use the execute button on this one The nice thing about this environment, we've tried to make it as easy as possible. So you can either copy and paste it manually, type it manually, or you can use the copy and paste command, or just the execute command, which will automatically copy and paste and enter it into your terminal, which is quite helpful. So what we've done there is we've created a new MicroProfile config properties file for our system microservice. So if we now open that up, you can see it's empty because I've only just created it. So in here, we're just going to put in 2 configuration values. The name of the service, and we're going to turn that telemetry on. So to turn it on, we need to put disabled to false. It's a weird, I have no idea why. It's so backwards. It's so weird, but it's what we need to do. So that's it for the system microservice, as you can see. We're going to use the same configuration values, just slightly different for inventory. All we're going to do is, for the same class, essentially, in the inventory microservice, it's already got 1 piece of information in there, but we're going to add in the other 2 that are needed. Copy and paste. So you can see all I've changed is the name of the service, but it's essentially, again, for the same purpose of making sure that it's switched on. Okay, so now that we've done that, we can run this curl command to, again, sort of run the system and inventory services, and now we can head back to the AUI. At the moment, I've got no services found because we didn't have any tracing already enabled in it. But if I refresh this page now, what we'll see is, hopefully, perfect. We've got the inventory and the system microservices. So if I go to inventory, for example, and click find traces, you can now see I've already got some traces, even though all I did was add it to my server.xml and make sure it was on in my config properties. I didn't actually make any code changes to my application. So if I click on that, you can start to see some information about some of those traces. We can start to go into the individual spans and get some more information, like I can look at the tags, for example, and find out what's happening within my application. So that's the automatic enrollment that you can get if you're already using things like Jakarta REST and MicroProfile REST client. What about enabling explicit tracing? So at the moment, all this has done is it's enabled me to be able to instrument. It's basically said, I think it's with all of them, So it's basically said, we're just going to collect everything we can for that application. But actually, we might want to be a bit more specific. We might want to add some additional information into each of our spans. We might want to add names in for them. And we might even want to add stuff in if we've not used Jakarta REST or MicroProfile REST client. So we can use things like the annotations like @span to be able to do this. So I've only got 5 minutes left, so I'm going to make this quick. So I'm just going to copy and paste in the pom.xml to be able to add in the dependencies I need to be able to utilize these annotations. So I can save that. So what we've done here is we've added in, let me add the server.xml. We've added in things like the Open Telemetry API dependency and the Open Telemetry instrumentation annotations. That second dependency is what allows us to be able to annotate and use the manual instrumentation. So if I open up the server.xml and then add in, again, we're not adding in much here. It's literally really small changes. But what I've done here is this line, which enables me to be able to expose those APIs as third-party APIs in OpenLiberty. And that enables me to be able to set the third-party value to the API type visibility attribute in the class loader configuration. So it's what's required if we're going to be utilizing these annotations. Then I can add the @span annotation to be able to add some more customization for those traces. So if I open up the inventory manager.java class and copy and paste in this code, I will show you what I've changed. So in here, you can start to see I'm using this @span annotation to manually add in those traces. Now, there's the option to add in a span name if I want to, but that's completely optional. So you can see in this case, for the list, I've not added in a span name, so it will just take the automatic. But in this case, with the add, I have added in my own name, so I can more explicitly see what I'm adding in. So it's really your choice as to whether you want to do that. We've also used things like span attribute, which is another annotation you can use to add additional information. So in this case, I'm adding in host name as the attribute name for the host parameter, just to show that I can add that information in. You can also check out the Open Telemetry website, which will show you more in the annotations that you can make use of. So now, if I remember to save, now if I hit this curl command and head to my Jaeger UI, let's refresh. It's probably easier actually if I go back. I've probably mocked this up now. Let's have a look. This is where my internet may not be particularly strong. All right, we're just going to try this again. Give it a minute. There we go. All right, find traces. So now when I go into it, let's have a look. Is this updated? The nice thing is what you can see is you can actually see, if I make this a little bit bigger, you can actually see that as I've been making changes to my application, you can see that my application has been updating on the fly because I've been running these in dev mode. So I can see those changes in real time. Let's try this one more time. See if we get anything different. Trying to see what I'm supposed to be seeing. No, I'm not seeing the additional information, so maybe I've made a mistake somewhere. Did anyone see me not save a file? Maybe that one? No. Okay, so for some reason my Jaeger UI is not working right now, but what you should see, which is what you'll see on the website, so you can always compare just to see in the instructions in case you haven't done it correctly, is what I should see is I should see those 2 additional spans that I added with the @span annotation showing up in my Jaeger UI. For some reason, the demo gods are not smiling on me today and don't want to show it, so I'm really sorry. We can't see it in the Jaeger UI right now, but hopefully you should be able to if you do this yourself at home. So that is the interactive guide, and I'll just quickly wrap up. Okay, so I know that was like a whistle-stop tour through telemetry, but hopefully what you learned from today is that we are entering a world of increasing complexity, but that we can learn from other industries and other professions like medicine and see where we can improve on our diagnosis by adding in that all-important context, that context being critical. And we can utilize open source frameworks and tools like Open Telemetry and MicroProfile to be able to do that in our own applications. If you want some additional work, as if I haven't given enough in this presentation, there's some more resources, and there's also links throughout the presentation, and I'll share those slides with you all afterwards. If you want to find out more about Open Liberty, then follow us on social media. I run the social media accounts, so I'll say hi if you give us a follow. Or use it as a way to provide us feedback. If you have any feedback on the guides at all, we'd absolutely love to hear them. If we're missing a guide, let us know. We're always looking to create more. So with that, I'm going to say thank you so much for sticking with me this whole time. I know it was really quick, but hopefully it gave you a good insight to just how easy it can be to add in things like tracing, using MicroProfile into your own applications. Thanks very much.